kickstarting the custom muscle vehicle project. The highlight is the oversized rocked-on truck tire, a two-tone gold and silver alloy rim. The engineer starts by checking the flange dimensions, measuring the thick steel plate for the central connection. Marking the bolt holes must be extremely precise. First, using a marker to mark the drilling spots. Any error will cause dynamic imbalance in the system. Second, moving to the drill press to create the mounting holes. The alloy drill bit cuts through the thick steel, arranging high-strength hex bolts. TIG welding them in place to create a permanent mounting point. An auxiliary flange is carefully measured. The engineer marks the center of the large plate to drill the main axle hole, using a large CNC hole saw to drill the center hole. This is where the main wheel axle will be housed. Welding the auxiliary flange to the heavy-duty cast steel tube, grinding the welds smooth with an angle grinder. First, pressing sealed bearings into the steel tube housing. This component reduces friction when the wheel axle rotates. Second, clamping the steel tube assembly into a mechanic's vise, inserting a threaded steel rod straight through the center of the bearings. Fabricating the secondary hub assembly with a small flange. High-temperature welding to fix the threaded connection pins. Fourth, temporarily tightening the nuts to hold the exact shape, preventing material shrinkage and heat distortion. Assembling the newly finished hub into the axle tube, using a wrench to tighten it, creating a solid, single-piece rotary axle assembly. Fifth, integrating a standard motorcycle brake disc. The axle braking system ensures linear and safe braking force. Sixth, mounting the axle assembly onto the center of the original giant steel plate, reinforcing it with bolts and anti-rotation lock nuts. Embedding the entire central flange assembly into the truck tire rim, cross-tightening the nuts to securely lock the front wheel to the steering axle. Starting work on the front suspension system, selecting two heavy-duty dual-spring shock absorbers. Inserting additional steel tubes for protection and reinforcement. Increasing the load-bearing capacity for the massive truck tire. Measuring and marking the steel plate to make the upper triple clamp. Drilling precise holes to connect the two fork ends in parallel. Fourth, welding a space frame structure using rectangular steel tubing. This frame transfers the compressive force from the wheel to the chassis. Fifth, fabricating the steering stem with a vertical pillar. Welding triangular gussets for reinforcement to prevent twisting and bending. Sixth, an HSS drill bit pierces the positioning steel plate.
Pause. Pause.
Preparing to install the pillow block bearings. Inserting bolts and tightening the washers and nuts. Two pillow block bearings are mounted in parallel to create the steering axle base. Using a wrench to firmly tighten the nuts and lock the system in place. This mechanism will bear all the torque when turning.
Pause.
Fourth, inserting a solid steel steering shaft through the center of the bearings, attaching the shaft retaining collars, checking for smooth operation without any wobbling, mounting a tracker-style handlebar to the top of the steering shaft. The basic steering system has started to take shape. Moving on to fabricating a T-joint for the front wheel axle.
Welding the brackets securely. Sliding them onto the shock absorber sleeves and tightening the screws. Securing the clamps with high-strength hex bolts. Pause. Completing the front fork assembly. Creating a load-bearing central mounting point for the front forks. Pause. Fabricating the fork clamps from steel pipes and hinges. Welding the brackets securely. Sliding them onto the shock absorber sleeves and tightening the screws. With an incredibly robust structure. Guiding the swing arm assembly directly into the wheel's central axle. Pause. Aligning the axle holes and tightening the lock nuts on both sides. The massive truck tire is successfully connected to the undercarriage. Pause. Installing the upper triple clamp steel plate to connect the two fork tops.
Using a wrench to tighten the locking bolts, keeping the forks parallel.
Pause.
Lifting the wheel and inserting the steering stem into the triple clamp hole. The aggressive front end is complete and ready to be attached. First, the engineer proceeds to select a rear tire from the old inventory. Second, wide car tires with alloy rims are chosen. Fourth, using digital calipers to measure the diameter of the rim center hole.
Pause.
This exact parameter is used to machine the drive hub flange.
Pause.
Fourth, using an alloy hole saw to cut through the steel plate. The center of the flange must be absolutely precise to align coaxially with the rim.
Pause.
Fifth, tack welding high-strength bolts onto the steel plate to create mounting points.
Pause.
Drilling holes in a cylindrical steel bushing in preparation for threading. Sixth, these threaded holes are used for set screws to prevent the drive shaft from slipping.
Pause. Pause.
Second, welding the bolted plate to the newly machined steel bushing, completing the central drive hub flange for the rear wheel.
Pause.
Spray lemon yellow paint to protect the surface against rust. The contrasting color creates an impressive sporty mechanical highlight. Install the newly dried hub flange into the rear cast wheel. Thread the spacer nuts and tighten them securely to lock the drivetrain assembly in place. Moving on to the fabrication of the main vehicle frame. Use thick rectangular steel tubing to weld and shape the undercarriage. The corners are chamfered at 45 degrees and TIG welded together to form a sturdy trapezoidal frame with beautiful fish scale welds, reinforced with horizontal steel crossmembers for central load bearing to ensure absolute rigidity for the chassis and prevent torsion. Shape and solidly weld the rear chassis structure. Use an angle grinder to smooth out the welding slag and flatten the mating surfaces. Plate and weld a thick, flat steel sheet onto the rear of the frame. This will be a solid mounting base. For the internal combustion engine, lift the large single-cylinder motorcycle engine onto the base. Align its position with a ruler and begin installing the engine mounting brackets. 1. Fabricate the engine mounting brackets from flat steel. Drill holes and insert bolts through the engine block to secure it. 2. Use a TIG welder to fuse the brackets to the mounting base. Deep penetration welds ensure the engine does not vibrate or shake. 3. Weld 2 footrest bars on both sides of the base. Standard footrest mechanisms help the rider stay comfortable. 1. Select secondary gears from an old gearbox. The engineer is calculating the gear ratio for the reverse gear assembly. 2. Cut a flat steel plate and use a hole saw to create round holes. This will be the load-bearing partition for the custom gearbox. 3. Weld 2 steel sleeves to act as housings for the roller bearings, ensuring absolute concentricity for the 2 gear shafts. Assemble the primary drive gear cluster into the steel partition. The steel shafts pass through the bearings smoothly without binding. 4. Proceed to weld the partitions together into a sealed box. The custom reverse gearbox is gradually taking shape. Weld an additional locking dog onto a small gear shaft, designing a sliding gear engagement mechanism using a push spring to install the shift shaft with a return spring into the gearbox. When the cable is pulled, the gear will slide the dogs to engage or disengage the clutch. Weld nuts as anchor points to bolt the cover on. Use an angle grinder to smooth the sharp edges of the box. Thread a steel clutch cable through a slot in the gearbox wall to hook the cable onto the sliding shift fork to control the reverse gear. To install the output sprocket onto the secondary shaft of the gearbox, tighten the lock nut securely with a pneumatic impact wrench. 4. Apply lubricating grease, seal the reverse gearbox cover, and tighten the bolts. The control cable assembly is neatly routed to the front. 5. Machine 2 square clamp brackets from rectangular steel tubing. Drill holes and weld captive nuts securely inside. 6. Weld these 2 clamp brackets to both sides of the reverse gearbox to create a sliding mount for adjusting the drive chain tension. 4. Place the reverse gearbox assembly on the chassis base behind the engine. Align the sprocket axis to be perfectly straight with the engine sprocket. 5. Weld the reverse gearbox mount securely to the main frame. Use a wrench to tighten the bolts and lock the gearbox in place. 2. Loop the drive chain around the engine sprocket and the reverse gearbox. Install the master to complete the primary drive system. Low. Install the chrome-plated gear shift lever onto the engine's shift shaft. The shifter is designed as a dual lever for convenient heel shifting. Route the reverse gear control cable along the frame. Install the inner cable into the auxiliary pedal-style lever on the left. 4. Tighten the nut to secure the cable end and test the spring's elasticity. Loosely install the kickstarter lever onto the right engine cover. Weld extensions to widen the contact surface for the foot brake pedal. I move on to the assembly of the rear axle with a differential. 4. Insert the large differential sprocket assembly into the middle of the load-bearing steel axle. Tighten the hex set screws to secure the differential to the axle. Slide 2 pillow block bearing housings onto both sides of the axle. This mechanism will suspend the entire rear axle assembly onto the chassis. Lift the entire rear axle assembly and place it onto the rear of the frame. Use wooden blocks as temporary supports to align the rear sprocket concentrically. 4. Precisely align the positions of the two bearing housings. Insert bolts through the holes in the steel chassis. 1. Use a wrench to securely tighten the nuts, completely fixing the rear axle to the vehicle frame. 2. Assemble the drive chain transmitting power from the reverse gearbox. Loop the chain over the large differential sprocket and install the master. Integrate the hydraulic disc brake caliper bracket onto the rear axle. Securely tighten the caliper mounting bolts to ensure safe braking force. Measure and bend the load, bearing round steel tubes, to shape the curved arches for the upper frame. The engineer puts on a welding helmet and proceeds to tack weld. High-temperature welds connect the steel tubes to the steering neck. Reinforce with diagonal crossbars made of small steel tubes, completing an extremely rigid space frame structure. Install the leather-upholstered seat with a diamond-stitched pattern. The rear of the seat is supported by a single shock absorber. Cut and weld a U-shaped steel bar to serve as the fuel tank mount. Test fit the bright yellow teardrop-shaped fuel tank. 1. The engineer sits on the vehicle to test its ergonomics. The seat's suspension travel operates very smoothly. 2. Assemble the disc brake calipers for the rear wheel assembly. Tighten the bolts, securing the brake assembly to the bracket. Install the hydraulic brake lever assembly onto the handlebar. Open the reservoir cap and pour in the reservoir. Specialized brake fluid. Slide the throttle tube and control switch onto the handlebar. Route the electrical wiring along the main frame. Connect the engine ignition system connectors. Screw the ground wire directly to the engine block. Install the battery box behind the engine. Connect the power terminals for the entire vehicle. Use a cordless drill to secure the large fuel tank. Insert the ignition switch assembly into the front steering neck. Mount the two angular, sports-style rear-view mirrors. The view from the handlebar is incredibly aggressive and powerful. To install the shiny stainless steel exhaust system, tighten the exhaust flange to the engine's exhaust port. Position the large radiator with a cooling fan. Screw and secure the radiator to the vehicle frame. Connect the rubber hoses for the coolant. Fill the radiator with coolant and tightly close the pressure cap. Install the black metal side covers to shield the engine. Begin assembling the hydraulic foot brake pedal. Secure the brake assembly to the right side of the frame. Install the auxiliary brake fluid reservoir for the rear brake system. Tighten the disc brake caliper on the rear wheel axle. Connect the high-pressure brake line to the caliper. Fill the reservoir with yellow brake fluid. Continuously squeeze and release the brake lever to bleed air bubbles from the line. Turn the ignition key to the on position. Press the start button and rev the throttle to make the engine roar. I step on the gear shifter to engage forward gear. The drivetrain immediately transmits power to the rear wheels. The drive chain powerfully turns the differential gear assembly. The two tires spin rapidly, demonstrating perfect concentricity. Step on the foot brake to halt the drivetrain. Remove the wooden support blocks from under the chassis. Install the vibrant three-tone side fairings. Use a screw gun to firmly secure the fairings to the frame. The engineer puts on a helmet and sits on the seat. Engages forward gear and twists the throttle to drive outside. The custom three-wheeled vehicle rolls majestically on the road. The giant front wheel creates an incredibly unique appearance. 5. The low chassis combined with the flexible dual shock absorbers. The differential drivetrain helps the vehicle corner stably. The vehicle accelerates smoothly, demonstrating excellent mechanical performance. A highly creative fabrication project has been a complete success. Use a tap to thread the drilled hole on the bushing.